Hello again, everyone. Good lunch? Thumbs up? Everything good? Excellent. Well, thank you again to Moog for the sponsorship of today's lunch. We really appreciate it. Let's see. Oh, so the answer to the trivia question, if we could get the slides back up again. Let's see. Oop. And there's your answer, 1990. He also received the NASA Distinguished Service Medal in '62, Congressional Space Medal of Honor in 1978, and the Medal of Freedom in 2012. So there you go. So before we get started with today's lunch presentation, lunch speaker, we have a special award to present. The AAS Space Life Sciences Award is given annually for outstanding results in two broad categories of research: results of space life sciences research on the ISS or elsewhere that benefit humanity overall, and discoveries of importance to conducting the human exploration of space. For example, effects of zero-G mitigation strategies. Our recipient this year is Dr. Millard Reschke, and he is being recognized for his exceptional scientific leadership and diplomacy for the benefit of space flight on human health and performance. Dr. Reschke currently serves as chief of the neuroscience laboratories at NASA Johnson Space Center, where they are concerned with the changes in the human sensory motor system during and after exposure of astronauts to sustained long-duration exposure to weightlessness, and the development of countermeasures to mitigate these changes. Dr. Reschke's accomplishments are simply too numerous to list out here. We will post the full nomination on our site, so I'll just mention a couple. He is currently the principal investigator for the Human Research Program funded field test study, a joint NASA-Russian investigation performed on astronauts and cosmonauts before and immediately after returning from long-duration missions on the ISS. For the first time ever, this study collects crew members' functional performance data immediately after landing, and then along the way home back to, for NASA astronauts, collecting valuable information on operational capabilities after gravitational transitions that will need to be considered for Orion and commercial missions. Dr. Reschke served as a co-investigator in a study that documented astronauts' impairment of balance on return from missions to Skylab, the first such study performed. He was also a missions scientist for Space Shuttle flights STA-125 to STS-125 to STS-135, and collaborated on studies on several other missions. Again, too much to spell out here, but needless to say, Dr. Reschke's impressive history of sustained and superior achievements for the JSC Human Health and Performance Directorate certainly make him very deserving of this award. Dr. Reschke, congratulations.
Thank you.
Absolutely. Would you like to make a comment?
Yeah, I would like to thank the AAS for, I always want to say ASS, but I got it right this time. So for the award, it's very special to me, and I certainly appreciate the recognition. Thank you all very much.
Thank you. I'll put this down. All right, and now on to our luncheon guest speaker. To introduce our speaker, I'd like to bring up Steve Witkowski of Moog. Steve?
Usually don't have a problem buttoning up my jacket, but today seems to be an issue. Just a couple thank yous out there before I introduce Fred here. First, I'd like to thank Dave Stringer. I saw him here for the great tour he gave yesterday out at the Plumbrook facility. If you folks haven't been out there, probably someplace where you'd want to get out to at some point. also like to thank Janet Cavandi and her team on all the hard work that they did to help put together this program for the inaugural Glenn Symposium here. And then finally, thank you all for coming on out to this symposium. You know, when you have something new, you're always wondering who's going to make it out for it. And I was really pleasantly surprised when I walked in today to see all the folks out here. So no further ado, I will introduce Dr. Fred Kennedy. He's recently departed from the SDA, as some of you may know. Before that, he in 2017, he became the SDA director, and before that, he worked in the the Tactical Technology Office for DARPA, which I know many of you know him from that activity. Prior to DARPA, he served as a senior policy advisor for the National Security, Space, and Aviation in the National Security and International Affairs Division of the White House Office of Science and Technology Policy. Say that 10 times in a row. In that role, Dr. Kennedy advised the President of the United States on matters related to space and aviation policy. Fred served 23 years in the United States Air Force. Thank you. And where he retired as a colonel. During his tenure, he served as a senior materials leader in both the Air Force Space and Missile Systems Centers, Remote Sensing Directorate, and the Air Force Life Cycle Management Center's Battle Management Directorate. They always seem to put you in these really long title areas. Prior to that, he was the lead for space requirements with the Joint Staff J8 in Capabilities and Acquisitions Division at the Pentagon, and a chief for spacecraft payload development and test and satellite systems and acquisitions at the National Reconnaissance Office. From 2005 to 2008, while in the Air Force, Dr. Kennedy was a program manager in TTO, where he created and managed efforts around spacecraft and satellite servicing, advanced space power and propulsion systems, and innovation, space, and technology. So very, very appropriate for what we're talking about here in the next 2 days. Dr. Kennedy does hold a PhD in electronics and physical sciences from the University of Surrey, a Master's of Arts in the organizational management from George Washington University, and a Master's of Science and Bachelor's of Science, both in aeronautics and astronautics from Massachusetts Institute of Technology. Fred's going to come up here today, and he wants to talk and have basically a conversation with us about innovation. So please give a warm welcome for Dr. Fred Kennedy. Thank you.
I really hate the title of my job I had when I was at the White House. It's about 14 words long, and every time somebody tries to say it, that's basically what happens. Steve, thank you for that intro anyway. As Steve noted, what I would really like to do is maybe talk for, 10 or 15 minutes, and just kind of give you my take on innovation, where we're headed in the space community, maybe where we should head, but then really just open it up and let's have a dialogue. I do much better with that. If you know me at all, you'll know this is much more fun if you just ask questions, and nothing's off the table. So just hit me with what you got, and we'll try to have a discussion of it. And it just turns out to be much more fun that way. Is that okay? All right, cool. All right. Just so you know, those Air Force jobs that Steve was talking about, one of them involves something very intriguing, the Orbital Express program, which we did with Boeing back in 2007, 2-satellite experiment to go off and demonstrate satellite servicing. That was actually quite successful. Hats off to the Boeing team and everybody on board. But boy, I tell you what, coming out of my doctoral work directly into DARPA and being able to do something like that was just tremendous, and it affected my life forever. And it was that spirit of innovation, the thought that you could actually do something totally different, that really drove me. That really sort of changed me. Because at that point, I wasn't quite sure whether I was within the Air Force, whether I was at the National Reconnaissance Office, whether we weren't just kind of stuck in the same rut, the same systems, the same builds over and over and over again ad infinitum. But spending that time at DARPA convinced me that at least there's a chance to inject new capabilities and new thinking. And it's kind of driven me ever since. So I'll get started. And this is just my prepared remarks, so pardon me on that one. Good afternoon. Thanks really so much to the organizers. Where's Jim? Where is he? Is he outside somewhere? He's got to be around here somewhere. Anyway, Jim Way, thanks so much for inviting me to come out and speak with you all today. This is my first opportunity to chat about space and where we're headed since I left the newly formed Space Development Agency, or SDA. I'd like to just note that I'm really here in the capacity of Fred, private citizen. I'm not representing DARPA, the Department of Defense, anybody else. It's just me talking, so have fun with that. I saw a very interesting comment on social media several days ago, and it involved this recent launch of 60 Starlink spacecraft by SpaceX. And basically the author was lamenting the fact that 3 of the 60 satellites that SpaceX launched appeared to have failed. The implication was the company could have and should have done better. And what I'm wondering is, what is good enough? What would good enough be? If you launch a single satellite, common sense tells you how many satellites need to work once they achieve orbit, and what failures look like, right? It's pretty binary. But if you put up 60, how many do you need to have work in order for you to be successful? And perhaps even those failures you experience might contribute to improvements in the next build, and it turns out because they're moving so quickly and building so many so fast, a build which won't take a decade and billions of dollars to complete. So your innovation cycle could be potentially very, very fast. So I think what the author there was doing wrongly, I mean, he's a good guy. I don't want to disparage him at all. He's bringing up what I would say is a cultural point. He's coming to this problem with a pathologically risk-averse focus on hyper-reliability to a situation where it is entirely inappropriate. But what it really illustrates is just strong our cultural imperative is towards zero defects. How we really play the failure is not an option game. And when you're talking about building hundreds or thousands of things, it's about what happens in the aggregate, not what happens at the unit level. And yet, it is so hard for our culture, and me too, folks, don't get me wrong. It is hard, because when I go to design review, I revert to form, right? I want it to work. I get it. But this is a different world we're moving into, and it's a good world to go to, because it is going to allow us to foster innovation in a way we have not seen. So, what if SpaceX had demanded that all 60 Starlink spacecraft work out of the box? What if the loss of even a single vehicle was unacceptable? Well, I suspect the company would probably still be performing part screening and maybe some low-level subsystem tests right now, and you wouldn't see a launch for probably another 2 or 3 years. The power of this proliferative capability, this proliferation, is in its ability to set us free from our single-minded obsession with unit reliability. A few satellites can fail, and that's perfectly all right because A, they weren't incredibly expensive, and B, they can be replaced in short order. Starlink was making these things in weeks. In weeks. Not years, not months, but weeks. Our national security space community, and frankly the broader space industry, has been living inside this mantra of zero defects for decades. And it's kept alive by claims that there are some things that only large, complex, monolithic satellites can do. I would tell you the status quo defenders who asserted just a decade ago that small satellites are just toys and who now say physics are physics, it's all predicated on the assumption that aggregates of small systems can't be more effective than monolithic large systems. Now that's a highly questionable assumption, and I think it's about to be put to the test. I've said this before, for many applications we still only build a small number of systems today, so everything has to work, it has to work well, and that tends to make our space programs take too long and cost too much. And that kills innovation. It just kills it outright. According to the Air Force, which I was once a part, we performed 75 national security launches in the last 25 years. Now that number is from March, so I think we're probably going to be over 80 or so by the end of the year, and Mark's telling me yes, so I'm going to go with that. The point is the average is about 3 annually, right? 3. Now, that's not a lot. If you want innovation, you need cadence, you need speed, right? That's got to be there. You need to be able to take what you've learned from a previous failure and immediately apply it to your next build. But that's really hard if you have to wait a decade for the next system to reach orbit. People get disenchanted, they get offered other opportunities, other jobs, they leave programs, and the learning is lost before it can be properly capitalized on. Now, again, no slam against my former service, none whatsoever, but it took us 24 years to complete the Air Force's newest ballistic missile early warning system, space-based infrared. I was part of the program, remote sensing directorate. 4 satellites, 2 payloads, 24 years, using focal planes designed in the 1980s and 1990s. For some of you youngsters, you may not have been born when these designs were started, and you should really think about that and ask yourself what it means for innovation. So that's the same amount of time between the end of World War II and the first manned lunar landing, okay? And according to best estimates, it cost us about $20 billion. The Navy started looking at a new communication satellite network in 2001 to replace an older one that they'd started back in the 90s. And their first launch was slated for 2009. That was delayed 3 years. The 5th and final launch made it to orbit in 2016. That's 15 years, $7 billion. This pattern is what is driving the death of innovation in our community. This is the problem. So, you might say, okay, Fred, you've diagnosed it. We've all heard it before. Thanks so much. So what we wanted to do at the Space Development Agency, at the SDA, was to address the central issue of risk aversion head on and build out a culture that was based not on reliability, but on a focus of speed, of response, and agility, which roughly translates as an ability to innovate. We believe the way forward would be through mass production, and that, see, I'm getting these text updates while I'm talking to you guys, this is great. And by the way, none of you text me right now, that's really rude. I have a buddy, former, he's at NGA now, and he found out that I was reading off my phone, and so he's texting me as I'm talking. I'm like, jerk! It's just covering up everything I'm saying, it's fantastic. It's absolutely true. Anyway. So we believe the way forward would be through mass production, and that applying the principles of mass production to elements of our space architecture would reduce cost, it would allow us to shorten our build and deployment cycles, and by doing so, it would encourage innovation. Because now we have multiple shots on goal to test out the approach and improve on short time frames. And you see, how we get there is not nearly as important as committing to doing it this way in the first place. We could lease services from commercial providers. And I'm saying this because I've been told that I'm out on off the reservation because I've suggested the leasing of services. But last time I checked, the Department of Defense actually leases a huge amount of communications capability the exact same way. We could buy spacecraft off various hot production lines or warm lines and then retrofit them appropriately, whether that's a Starlink or a OneWeb or a Kuiper or a Telesat or a LeoSat. I don't care. But if those lines are out there, why wouldn't you try to leverage them and at least get some of that capability back? I like to call this the Model T approach, right? Once you've purchased the base model car, you can turn it into whatever you want, and people did. They turned Model Ts into tractors because they could buy that base model, which was cheap, inexpensive, right, easy to get off the line, and they do whatever they wanted with it. And that's really what I'm talking about here. Why go back to the drawing board and reinvent the bus, reinvent all that, when it's sitting there waiting for you? I mean, you might do it because you don't like the jitter characteristics or something. I get all that, okay? But there are ways to take some of that out. Just like the person who purchased the Model T. Use what's available, retrofit with your capability, and press. And getting those costs out, getting the time out, that's where the innovation comes back in. That's where everybody starts saying, I have an idea about what we could do with that. And we could actually implement it next year rather than 10 years from now. Finally, if you're truly fearful of where all this, quote-unquote new space is heading, right? If you really are scared that none of these commercial business cases will ever close and the SoftBanks and the Bezoses and the Musks are totally out to lunch and nothing is ever going to pan out, which that's certainly one way to look at it, and that we will be left holding the bag, and we could be DOD, we could be NASA, we could be anybody. We might also look for opportunities to draw on lessons learned and best practices from the things that are going on now, because the innovation is happening now. So even if we don't believe in the commercial business cases, why wouldn't we try to leverage the wonderful best practices that are emerging and capitalize on them to ensure that our defense industrial base, and in this case a civil space industrial base, is able to apply lessons learned and start to build more quickly and affordably? You know, this really isn't much of a stretch because the mass production techniques we're talking about are already applied by the same defense industrial entities that build things like missiles, firearms, and vehicles, airplanes, you name it. They simply haven't brought their production lines over into space, and they probably won't do so until they see the obvious demand signal and the potential return on investment. That's really too bad because it seems to me that one or more of these entities could try to take the lead and demonstrate their ability to move us to a better place, to a more agile and responsive place. And they haven't yet, but maybe they will, once one or more of them determines that it's in their best interest to do so. So now where does that leave us today? Well, commercial is moving out. They're not waiting for the government to figure out what to do. These entities are out there rolling, they're investing, satellites are going to orbit. I think it's fantastic. OneWeb launches 32. Tim, where are you? Sometime soon. 34. Soyuz? Okay, got it. You know, what are you going to do? Won't work for me, but you know, actually it might work for me now that I think about it. Yeah. So bottom line, OneWeb's moving out. Starlink's going to put up more spacecraft. Is SpaceX people in the audience? Anybody from SpaceX? No? Okay. Oh, wait. Okay, cool. You guys are going to go up soon with more satellites, right? I assume. Yeah. He's like, no. Yeah, okay, whatever. Don't tell Elon. All right. And then others such as Amazon's Kuiper, Telesat, they're all working their own efforts, and they plan to place large numbers of spacecraft on orbit in the near term. And so my takeaway is from all this is that we shouldn't wait to see what's about to happen with this commercial surge and whether it has legs or not. We should invest appropriately now, whether you're in government, other industry, academia, and be ready for the shift in culture that's coming. Because it's not going to present itself in an obvious way. You're not going to know it's happened until after the break. And then we're all going to say, oh, we all saw that coming. And I wish we'd put some money into that because, you know, we probably would have made some. This change will come, and if we jump on board early, it may make all that difference. It really might. So that's my takeaway. I believe that we have a unique opportunity right now with significant commercial dollars pouring in to change the way we innovate in space. I would even go further and to say to allow us to innovate in space because we aren't doing it very well today. But that cycle of innovation, compressing it, and doing so on the backs of mass production techniques, on small satellites, on the micro computer revolution, all of these things are giving us, I would say, a perfect storm today that we should try to take advantage of. And if we don't, it's our own damn fault if we don't get on board and fix it. So with that, those are my quasi-prepared remarks. I'm happy to take questions. As I said, I'm happy to answer anything you might want to ask. Just, you know, be nice.
Excellent. So again, just wave your hand like crazy if you have a question in the room, but we'll start off with one that's submitted via the conference I/O.
Okay.
So for engineers with an interest in policy roles in the future, what experiences would you recommend?
Engineers who want to be policy types?
Yeah.
You should probably ask Mark. But yeah, I knew you'd like that. So I had the opportunity to get into a policy role. I wasn't in it for very long, but it was fascinating. And coming in with the engineer's mindset and mentality was huge because the questions that were being posed, honestly, often demanded you to roll back into some very basic engineering just to answer the questions. People were really operating in fact-free environments, and opinions were, you know, floating around. All you had to do is come in and say, you know, it turns out that a solid rocket motor does X. And everybody went, oh, well, then that means this isn't an issue at all. I said, thank you. Can we move on, right? It's those kind of things which make people hate engineers. But at the same time, it's very hard to argue with. So what I would say is, as you're moving along in your career, I would not recommend to a young engineer to do this right away. I think it makes you stale. But I do suggest that if you're 15, 20 years in and you want to see what you can do to really affect things at the policy level to change the way the government is going to operate or should operate. If you're feeling pretty irritated because of your concerns with ITAR or remote sensing or you name it, by all means, if you've got the good background, the policy community would love to have you because they can use that strong engineering discipline and sense that will inform better decision making. It's needed, and it isn't there as often as it should be. I think would you agree with me on that for the most part? Okay. If I said it's true, that's good. That never used to be the case.
Anybody else? Frank? Microphone's coming to you that way.
Hi, Frank.
Thanks for coming today.
Good to see you.
Real question. Space Force obviously is having its challenges on the Hill, but
It is.
Fundamentally, one of the goals, from what I understood, was to try to create a separate mentality to see space as a domain in a different way. Do you think that would or will potentially someday facilitate the types of change you're talking about, or is that completely different?
No, I don't think it's orthogonal or anything. I think it's all of a piece. I think that the thought process that leads to a Space Force is a good one. I do believe in the same way we needed an Air Force, we probably do need something like a Space Force. We talked about air-mindedness at one point and why you had to have people who understood the promise and the value of the air campaign, independent of how it would specifically assist people on the ground or in the maritime environment. I think that's true here too. I think you have to have some component of space-mindedness in the Space Force, and I think that's the biggest thing you could have. It's the advocacy and the understanding of the domain at a very technical level. It's not enough to just say, I'm a Space Force guy or gal. I believe again, we talked about engineering a minute ago, this is where it's going to be dreadfully important. I think in order to do it right, you're going to have a significant technical component in the Space Force to get its job done at all. Folks are going to be very sharp on this to get anywhere at all. So that's important. But no, I think we do need to go there. If not, it's always relegated to second fiddle. The thing I would tell you, though, Frank, and you probably won't be surprised by this, is not having had a major war that included space, it's difficult to convince people that it just has to be there. And until you have some event which is seminal, the 9/11 of space, the Pearl Harbor of space, I just question how much people are going to be willing to do. It's difficult to imagine the scenario until the scenario has occurred, and then everybody gets it, and we're all questioned as to why we hadn't done anything about it until now. So, thanks, Frank. Good to see you.
Excellent. And let's go with another submitted question first, and then we'll get to the in-person one over there. So this one has to do with the requirements to innovate, and basically the question is, how do you think the reliance on heritage can be broken, which is required to innovate?
Well, I guess a lot of what I'm suggesting is that reliance on heritage does need to be broken, and that if people are putting up new capabilities and just testing them out to see if they work at all is a good thing. And if you can put up 60 satellites and 57 of them work, and we tried something new in the process, well then great. And I didn't have to go through 6 months of thermal vac and all the rest. That to me is absolutely critical. That sense that only heritage can fly is crazy. We should not be in that world. I think I was mentioning this to Jim. I may have mentioned it to you earlier. We heard Jeff Bezos say at his Blue Moon event in D.C. A few weeks back, maybe a month back or so, he talked about the idea that he wanted to be able to see kids in a garage be able to develop capability and get it on orbit. Well, you're not going to do that if I have to go to a 6-foot thermal vac chamber somewhere, right? That's just not going to happen. So we should be willing to throw things on orbit and see if they work, which means no reliance on heritage. That's where the innovation is going to come in. What are you thinking?
But to that, what about the risk? I mean,
the risk of what?
So the big
risk of what?
reward. Well,
The risk of failure?
No, contamination,
Of what?
space debris, things like that. If you put up 60 and only 30 work, and then you got the other 30 floating around dangerously.
Okay, well, they probably shouldn't go to space station orbit. But I would say if they're going to, where's Starlink? 350 miles started out?
We started below space station.
Where, 350?
Yeah, for exactly that reason.
Exactly.
Did the orbit raising above space station.
Right. So what I would say is you need to do some obvious potential remediation to ensure that if something did fail, that it's going to come back. So I wouldn't recommend you throw it to GEO that way, but But I think, if you take the proper precautions, then those risks are minimal. Yeah, I think that's the key. So I'm not saying that you just happen to have a refrigerator, you want to see what it does on orbit, you should just throw it up and see what happens. But I do suggest that if you do have a new idea and you can't find obvious legacy investors to come forward and give you all the test apparatus and all the capability, that you can erase that energy barrier and do something new. That's what's so critical. So I do say do away with the tyranny of heritage. I think that's killing us. The S parts thing, it's driving us into insanity. I'm happy to use processors, memory, you name it, that just came out of Best Buy for all I care. And if my satellite has to work for a year, maybe that's enough. Maybe I can be, maybe I can be rad tolerant by design, right? If I use just a couple more Raspberry Pis, maybe I can get there,
We have a question back there.
You have a rich set of experience in a wide range of different parts of the government. Is there one organization that you can tell us about that you think has the best investment in seed corn? Because a lot of our government organizations, the seed corn is being
mishandled,
subsumed by projects and all that. So there's, like, for example, a small agency called NASA, back in 1997 had its RTOP, Research Technology Objectives and Plans, ripped away by a certain administrator who we won't bring up. And all that was the seed corn for everything, aeronautics, space, everything.
You probably won't be surprised by my answer. It's DARPA. DARPA, like any organization, has its warts, but DARPA is very good at doing exactly what you're saying here, taking sort of the unheralded and unknown and bringing it forward and allowing a very smart engineer or scientist to press to completion with a real capability. I see DARPA do that better than anybody. I can't point to anything in the services that's as good. I would say that the unique thing about DARPA is you're essentially permitted the autonomy and provided the resources to get your job done. And as long as you've made the director happy, you're good to go. And it's nice to have that, right? Because the more coordination, the more boards that have to meet, the more organizations that have to get involved in order for you to do your thing, that's death, right? You don't move fast that way. So DARPA is fairly quick that way, and I hope they preserve that, because that is one of the principal value adds at DARPA that I think is just so important. And again, like I said, it was seminal for me to go there, and it totally ruined me forever after, because I expected that kind of behavior to at least be imprintable on the other organizations that I went to work for. And what you discover is, wow, that's really hard, right? Because even if people want to do it, they don't believe it. Even if you come in at the head of an organization like that and say, I'm here, I'm your new boss, and I'm telling you, we are going to innovate here, we're going to move faster, and here's how we're going to do it, everybody's like, right. He'll be gone in a couple of years, that's bullshit, I don't buy that. Right? So that would be my answer. But the problem is it's hard to replicate. I don't know how to take a DARPA and put it anywhere else. I would argue that there's not been a truly successful DARPA clone. Sorry?
Well, what about Skunk Works? Something like
At one
that.
time. I mean, 1959.
Right.
Yeah, I agree, yeah. But what happens? Over time, organizations mature and mature some more. They grow a little senescent and fat. A lot of red tape, even in what we would call, even the Kelly Johnson style organizations. They all accrete bureaucracy. They all ossify. And I tell you, for my part, I'm a big fan of the sunset clause. I think organizations should be forced to shut down. You should say, you've got a 20-year lease on life. Be innovative, and in 20 years we'll come back and we're probably going to shut you down. But if you still look like you're doing something of value, and it's not just because you've got 48 states worth of help, maybe we'll let you live. But I think that sunset clause is critical. I think we need to renew ourselves more often. New organizations, new philosophies, and if we don't do that, we're going to be stuck with the same old forever. I think General John Hyten, he's in the news here. He said this very well. He said he looked back at the last 20 years of where we've been going in Air Force space. He said, I don't see any change at all. He said, what is going on here? This can't be right. And I'm with him. We need to figure out how to fix this.
So related to that, one of the questions online through the app, talks about changes in culture to promote innovation. And so the question really is, what kind of real grassroots or bottom-up actions can be taken to enable, a more innovative workplace?
Yeah.
I mean, your time at DARPA would, speak directly to that.
Well, and of course, what you heard me say about DARPA is that it's so difficult to translate into other organizations that have, very strong cultures. So it is very hard to come in, especially at a lower level, and then say, I demand that you all become an innovative culture. But even if you come in at the top, I've spoken with leaders in the Air Force and elsewhere who, I commiserate with about, you come in at the 3 or 4 star level and you still can't make that change. Cultural barriers are incredibly strong. Right? It's very hard to get through them. That's why, frankly, that's why we came up with the Space Development Agency, was because we wanted to start fresh. We weren't concerned about what other organizations were doing. We got what they were doing. We didn't want to do their job. But we wanted to start something new because we knew there was no way to go fix the old culture in a reasonable amount of time. The normal way to fix a culture is to fire 75% of the people in it. And usually that's not an acceptable outcome to anybody, including Congress and others. So the bottom line is, if you want to really make headway, you probably have to stand up your own company, or if you're a company, you have to stand up an autonomous unit that doesn't know it's part of that company. And in the government, you have to stand up a new agency or an office or an activity and then bring the right people to bear and give it a shot. Now, will it work? Who knows? It's a gamble.
So going back to a previous question, just about, put it up there and see if it works kind of thing. So if we implement that vision, how do we address the social perception that we're just recklessly polluting space?
Well, I mean, that's a good question. I think it kind of gets back to the necessity to be responsible. We need to be able to demonstrate that we are. And this is a policy question. The bottom line is, no one should be allowed just to throw stuff up willy-nilly. And I don't think that's ever going to be a place we're going to live in. I would be very surprised if someone just suddenly says, you know what, the FAA won't issue launch authorizations anymore, just fire away and see what happens, right? We're never going to be in that position. The question really is, how can we do this responsibly so that it in fact isn't the case of us just throwing up random gear into orbit to see what happens. I don't think that's where we are today, and I think we can certainly work with industry and with the government and academia, frankly, and others, and international partners to make sure that what does go up meets guidelines. I mean, I'm all for that, but I also think that that's not the problem we have today. It's not the issue of putting up too much. The fact that we're seeing people who are so concerned after seeing Starlink launch 60 satellites is kind of indicative of the fact that we may have the problem the other direction, right? And they put up 60, and oh my God, we just can't do that. Like, what are you talking about?
Let's see if we have another one here. There's one that's a little bit of an elephant in the room kind of question.
That's all right. You can go for it. I'll do my best. I knew they'd come, so.
All right. Well, here it is.
Is it good?
Are you ready?
Yeah.
You ready? All right. There's a lot of churn at the top.
Really?
Really? You don't say. Across civil and military space. When will this settle down? If it will.
Okay.
And what do you think the landscape will look like? Where's that crystal ball? Take it out.
Yeah, I know.
Start thinking.
Well, actually, that's not a bad elephant in the room question. That's a pretty good one. I was thinking it was going to have names and other things in it, so that's good. Since it doesn't, that helps a lot. I guess what I'd say to that is I do believe, again, that there is a looming cultural shift in space. And you can either decide to get on or not. And all that's going to do, really, is it's going to delay that onset. But I think the shift is coming. I think there's enough interest, enough investment dollars, enough activity. You're watching what's happened on the commercial side. You saw what happened at NASA with commercial crew and cargo. This is inevitable. It's coming. It just may not happen tomorrow. It may end up happening 5 years from now because of the status quo forces which are going to try to drive against it. But I think it's going to happen. So that's what I think about the settle out part. I think we're going to settle into a new phase, right? We're not going to be in this kind of risk-averse, launch one, wait 10 years, launch another. I don't think we're going to live there forever. And I don't even think we're going to live there in 10 years. But I can't tell you when the break point is. And if I could, I should probably go invest appropriately and make some money, right? So, yeah.
All right.
Hey, back to the innovation. There are a lot of countries that are getting into the space business, and that don't have the burden of 50 years of heritage that we have. Do you see pockets of innovation in them, or are they adopting different cultures? And where do you see those differences?
I just go back to my own experience. Back in the late 90s, I had a mentor tell me that I needed to go over to the UK and do some degree work because somebody had figured out how to build small satellites extremely inexpensively and extremely fast with a very small group of people. And they were right. They did. There are pockets of innovation out there that are not hampered by the kinds of constraints we have. I mean, look at the rise of the cell structure in China, right? Not hampered by a massive landline problem, right? All the installed infrastructure. Where the installed infrastructure isn't, people can take advantage of that and they can make hay. Look at New Zealand with launch. What does the New Zealand regulatory picture look like with regard to launch? It's pretty clean. Now, maybe it won't stay that way, but for now it's pretty clean. And if you keep in your mind the whole point of this is to innovate and move rapidly, maybe you can keep those forces at bay. They'll always be there, the rent seekers, the protectionists, right? They're going to find a way to make it hard. But yeah, it's out there. It's absolutely out there. I won't even name the obvious ones, right? Because there are groups of people out there that have a lot of degrees, a lot of good work going on in large countries who may not necessarily be our friends, all right? And they're thinking about this, absolutely. So that should be on our mind as well. It's a good question. Thank you.
All right, thank you, Fred. Picking up on the theme of innovation and mass production, another dimension of rapid refresh is the ability to add an incremental capability right over time.
Agree.
You talk a little bit about your thoughts on enabling greater capability over, say, a 15-year period of refreshes every 3 years, right? 5 increments versus a one-shot 15-year development.
Happy to talk about that. In fact, that was one of the tenets of the agency, was to go forth on 2-year centered tranches. We talked about putting up our initial capability in 22. Some people said, whoa, that's what, 2 years away? Like, yeah, that's right, and we're going to do it. We're going to do it on the backs of commercial capability. We're going to do it on the backs potentially of commercial buses or lease services, or perhaps even an enlightened defense industrial entity that came forward and said, I'm going to build a production line based on what I found out. So yeah, and then the thought was every 2 years after that, I have an opportunity to go back in a very agile-like structure to say, I want to hit these dates. The dates are the most important thing to me. I'm less concerned about what goes up, but I want to hit the dates. So give me a minimum viable product in 22 and make it better in 24, better in 26, better in 28. And I really wanted to emulate the cell phone or microcomputer market, right? Why would we not do that? This is not the iPhone of 2005. It's incredibly better in all ways, right? If we had done this in DOD, well, anyway, we wouldn't have a phone, but sorry. Brick of, you understand. So that is what I believe is the real power, is that iterative, right? That iterative improvement. Because what will happen is, by 2030, I believe you'd have, let's just pick a mission area, you would have an early warning and missile defense capability after that iterative process that would totally outstrip anything you would have done in the monolithic realm. And you're only going to get the monolithic version in 2030 anyway. So I've got 5 or 6 shots at the apple if I can continue to iterate and get better and better and better and better. So I thought that was an interesting place to go take the agency, and I thought it was important. And 2-year centers was what I was really looking at, 2 years. And I think that's doable if you've got hot production lines for buses and potentially hot production lines for payloads, which I know is tough in some sense, right? I'm talking about optics and all the rest, right? Supply chain issues are going to kill you all the way around. Just ask any of our current mega constellation players about how much fun they're having there. So, yeah.
All right, so I think we got time for one more. I think it's a pretty good one. So we talked a lot about, just throwing stuff up there, see if it works, and use whatever you got, kind of thing.
Yeah.
How do you apply that when there's you inside it, or a human being inside it? What do you do when you start taking into the human factors?
Yeah, this is a tough one, and I will admit that having done my career on the DoD side, it doesn't come up as much, since our space community is an unmanned one, and we haven't put people up there in a long time. Well, we do. We call them astronauts and send them over to NASA and let them work for you guys. It's a hard one. I don't know if there's a politic answer to this. At some point, though, people will die in space. The question is, what is the appropriate risk posture to take? As long as we're putting 1 or 2 or 5 people in space, my guess is it's kind of analogous to what we're talking about with multi-billion-dollar assets, right? We're talking about people who are just too important and too capable and too renowned, or you name it. We're not going to lose them well. We're not going to want to lose them at all. I don't know where this goes. But, again, perhaps when there are tens of thousands or millions of people in space, there's a different answer for our risk posture. I mean, that may even sound a bit crass, but I think the truth of it is, at some point, we're going to treat space like just another domain that we live in. And I hate to say it, but people die on the roads every day in America. I think the number is 40,000 a year. And I would think that someone should lament that fact and be concerned about it. If we truly lamented it, we'd probably try to stop all those people from dying. Those are people just like the astronauts. Yeah. Yep. Yep. Thank you.